Welcome back. We are now on lesson 6.2, solving equations. When solving equations, we really want to try to get all of the x's on one side and all of the numbers on the other side. Sometimes that's pretty easy, other times it's a little bit difficult. So today we're going to show you a bunch of different examples so that you can solve equations. In this case, where we have 3x minus the quantity 2x plus 3, and that's equal to 2x minus 8. First thing we want to do is distribute this negative so that we have 3x minus 2x minus 3 equals 2x minus 8. Next thing we want to do is combine like terms. So on this left side we have a 3x minus a 2x, that's just x. We have a minus 3. On the right side we still have our 2x minus 8. At this point I want to get the x's on the same side. This 2x on the right side is the bigger one, so I'm just going to subtract x from both sides. That leaves me with negative 3 is equal to x minus 8. Now I can add the 8 over to the left side, and that gives me my answer that x is equal to 5. Here's another example that we have the square root of x plus 3, and that equals 4. To solve this one, we need to get rid of this square root. So the first thing we want to do is square both sides. Square the left side of the equation, square the right side of the equation. On the left side, the square root and the square, they cancel each other, so I get x plus 3. On the right side, 4 squared is 16. Now I can subtract 3, and I get that x equals 13. Anytime you square an equation, you always want to check your answer to make sure that this works. Because sometimes you get answers that don't actually work, and those are called extraneous solutions. We'll run into those a few times during this lesson. So we're going to plug this back in. The square root of 13 plus 3, does that equal 4? 13 plus 3 is 16. The square root of 16 does equal 4, so it checks out. X equals 13 is the correct solution. Here's another example. We've got 2x plus 3 equals x, so the square root of 2x plus 3, and that is equal to x. Again, we want to get rid of this square root. To do that, we're going to square both sides. The square root and the square cancel each other on the left side, so you have 2x plus 3. On the right side, you have x squared. Notice since we have an x squared, we're going to have to factor. So to do that, I'm going to move all of the items over to be with the x squared. So that's going to give me 0 is equal to x squared minus 2x minus 3. Which means now we need to factor. So we need two numbers that multiply to negative 3 and add to negative 2. Since there's not a leading coefficient, this is the easy factoring, which is you're going to use a negative 3 and a positive 1. Because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. Now, for those factors to equal 0, either x is 3 or x is negative 1. Now again, we want to plug these back into the original problem to see if they both work. So if we plug in a 3, that means we have the square root of 2 times 3 plus 3, and does that equal 3? So 2 times 3 is 6, plus 3 is 9. Does the square root of 9 equal 3? Yes, it does, so that is a solution. That one works. We look at negative 1. So we take the square root of 2 times negative 1 plus 3. does that equal negative 1? So 2 times negative 1, that's negative 2, plus 3 is 1. Does the square root of 1 equal negative 1? No, it doesn't. So that one is not a solution. It's called an extraneous solution. Meaning it's an extra solution that we got when we squared both sides. So x equals 3 is our only answer. Now, just because you have two answers does not mean that one of them is extraneous. Both of them could work. That's why we have to check both. And also, both of them could be extraneous. So we need to check both answers after we found them if we've ever squared anything from the original equation.